Known around the world as the Northern Lights, the Aurora Borealis produces one of our planet's most breathtaking nighttime spectacles. But what causes this extraordinary natural light show? Every aurora begins 93 million miles away at the heart of the Sun. Our Sun is a massive fusion reactor, smashing hydrogen atoms together so fast they melt into plasma, a strange semi-gas-like state of matter that holds a powerful magnetic charge. Every once in a while, this plasma is expelled into space as clouds of energy we call the solar wind. As they approach Earth, these plasma clouds enter our planet's magnetic field, the magnetosphere. The magnetosphere wraps our planet like a protective cage, repelling the magnetized clouds, directing them around the Earth and back into space. Sometimes, though, when sunspot activity is at its height, the solar wind is stronger than usual. Sunspots are dark patches on the surface of the Sun where the Sun's magnetic field twists violently, causing the plasma to be ejected from the surface at an accelerated rate. When these superfast plasma clouds arrive at our atmosphere, they can smash right through our magnetosphere and into the denser layer directly below, the ionosphere, where the particles in the cloud are destroyed, releasing energy as color. The most abundant gases in our atmosphere are nitrogen and oxygen. If a plasma particle collides with an oxygen atom, it flares red, green, or yellow. If it collides with a nitrogen atom, it flares blue or purple. And then, for as little as 15 minutes, tourists in the right place at the right time are given a dazzling once-in-a-lifetime sky show. As alluring as these light displays are, scientists and defense departments have to pay close attention to the solar wind due to the troublesome effects it can have on our planet. Solar wind emissions, if strong enough, can burst through the ionosphere, causing a geomagnetic storm that can lead to widespread voltage problems on the Earth's surface, disrupting our electronics, our phone signals, and our power grids. And these emissions can even play havoc with our satellites. In February 2022, Elon Musk launched 49 Starlink satellites into a low Earth orbit in the ionosphere. Every Starlink satellite has an onboard engine that thrusts it out of the ionosphere after launch, pushing it into a higher orbit. But at entirely the wrong time, a geomagnetic storm struck, with the plasma from the incoming solar wind adding density to the atmosphere, causing increased drag. 40 of the satellites were unable to overcome the drag, and gravity pulled them back toward Earth, causing them to burn up as they descended, costing SpaceX an uncomfortable $50 million. While solar wind eruptions are largely unpredictable, our astrophysicists have observed that their intensity rises and lowers in 11-year cycles. The low point of solar activity is called the solar minimum, the high point, the solar maximum. At the time of this recording, the solar maximum is happening right now, starting in January of 2024 and expected to last until October, a stretch of time where our electronics and our infrastructure will be at their most vulnerable. Did you notice any disruptions to your phone or Wi-Fi communications during this time? Have you been lucky enough to witness an aurora firsthand? Leave your thoughts in the comments. And if you like content by the Unraveled channel, leave us a like and click the subscribe button to be notified when new content is available.